Hello viewers, in today's session we are going to discuss another important problem from functional equations. And in this session we are going to discuss this problem where we are given a function f of x as such that f of x plus y is equal to f of x plus f of y plus e raised to x minus 1 times e raised to y minus 1 for all x y belonging to the set of real numbers. And further we are given that f of x is a differentiable function, and we are given that f prime of 0 is equal to minus 2, right? And we have to find the form of the function f of x, or the function f of x satisfying this functional equation, right? So let us start. So let us call this functional equation as equation number 1, and let us start by substituting x is equal to y is equal to 0. So here let us substitute x is equal to 0 and y is equal to 0 to get the value of f of 0, right? So we have f of 0 plus 0. Here we have f of 0, f of 0, and here we have e raised to 0 minus 1, e raised to 0 minus 1. So this is f of 0, and here f of 0 plus f of 0 is 2 times f of 0, and e raised to 0 is 1, so we have 1 minus 1. Here also we have 1 minus 1. So f of 0 minus 2 times f of 0, taking 2 times f of 0 to the left hand side, and this is 1 minus 1 0 and 1 minus 1 0. So here we have 0. So we have minus f of 0 is equal to 0, and this implies that we have f of 0 is equal to 0, right? So we have an important result: f of 0 is equal to 0. And moreover we are also given in the problem that f prime of 0 is equal to minus 2. So we'll utilize these results in the later part of this problem. So now the second step is to make use of the concept of partial differentiation, right? So let us differentiate this equation 1 partially with respect to x. It means we have to keep y as constant. So we can now write del over del x of f of x plus y, and here we have del by del x of f of x, and here the this term, that is f of y, is a constant because we are differentiating partially with respect to x. So this term, the derivative of f of y with respect to x is 0, and here we have del by del x of e raised to x minus 1, e raised to y minus 1, right? Now the derivative of f of x plus y is simply f prime of x plus y, and then by chain rule we have the derivative of x plus y, and here del by del x of f of x is f prime of x, and then here e raised to y minus 1 is a constant, so we can take it outside this operator, and we have del by del x of e raised to x minus 1. So here the derivative of x with respect to x is 1, and the derivative of y with respect to x is 0, right? So this is 1 plus 0 1, so f prime of x plus y times 1 is simply f prime of x plus y, and here we have f prime of x, and here e raised to y minus 1. The derivative of e raised to x with respect to x is e raised to x, and the derivative of 1 with respect to x is 0, so we have simply e raised to x. So let us call this equation as equation number 2. So now we have this important equation, right? So let us substitute here x is equal to 0. So when we take x is equal to 0 in equation 2, we have f prime of 0 plus y, and here we have f prime of 0, and then e raised to y minus 1 e raised to 0. Now this is f prime of 0 plus y is y, and f prime of 0 can be replaced by minus 2, and then we have e raised to y minus 1, and e raised to 0 is 1. So we have f prime of y is equal to minus 2 plus e raised to y minus 1, and that is equal to e raised to y minus 3. Minus 2 minus 1 is minus 3. So now we have this important differential equation, that is f prime of y is equal to e raised to y minus 3. Now this can be written as df over dy is equal to e raised to y minus 3. We can now write df is equal to e raised to y minus 3 dy. Now integrating both sides with respect to here with respect to y, and k is the constant of integration, right? So integral df is simply f, and f is f of y. So we have now f of y, and here the integral of e raised to y is e raised to y, and the integral 3 dy is simply 3y, and k is the constant of integration. So here we have now f of y is equal to e raised to y minus 3y plus k, and this is our equation number 3, right? So let us replace this y by x. So we have now f of x is equal to e raised to x minus 3x plus k, right? And this is our equation 4. So now we have obtained the form of the function as equation number 4, right? And now we need to find out the constant of integration k. So let us use this result, that is f of 0 is equal to 0, right? So taking x is equal to 0 in this equation number 4, we have f of 0, then we have e raised to 0 minus 3 times 0 plus k, and f of 0 is equal to 0. So here we have 0, e raised to 0 is 1, and this is 0, and here we have plus k. So we have 0 is equal to 1 plus k, and this implies k is equal to minus 1. So taking k is equal to minus 1 over here, the form of the function, or the function f of x, which is to be determined, is now given by e raised to x minus 3x minus 1, taking k is equal to minus 1. So this is the required function f of x which satisfies this functional equation.